Yellowstone National Park's supervolcano is making headlines again as scientists detect changes in its magma chamber that could precede an eruption. But while Yellowstone gets all the attention, it isn't the only potential supervolcano threat we face. There are several other volcanoes around the world that have the capability to blow with similar force as the one at Yellowstone, and some of them are much closer to civilization. So here's what you need to know about the next global supervolcano threat. It's me, and you're watching this channel. If you haven't been living under a rock, you know that Yellowstone National Park's supervolcano has been making headlines lately. In a paper published this summer, researchers revealed that they had discovered significant changes in the movement of magma beneath the park's famous geysers and hot springs, including a 30% increase in gas emissions from some areas, which indicates more magma has been rising into the shallow magma chamber below the park. Now, this isn't cause for concern because the chances of an eruption in any given year are extremely low, somewhere between 1 in 250,000 and 1 in 750,000. Plus, eruptions at Yellowstone typically give us plenty of warning signs before they happen. Scientists monitor the park closely for any indication that an eruption is on the horizon. Still, it got us thinking what other supervolcanoes might pose a threat to our planet and how we can stay safe if one of them erupts. Volcanoes aren't created equal. They're ranked according to their height and how explosively they erupt. On the top of the pile are stratovolcanoes, also known as composite volcanoes, which are characterized by their conical shape and alternating layers of ash and lava. Stratovolcanoes tend to be the ones that capture our imaginations when we think about volcanoes. Mount Fuji in Japan and Mount Vesuvius in Italy, which famously destroyed the Roman city of Pompeii, are both stratovolcanoes. However, when it comes to sheer destructive power, stratovolcanoes are small fry compared to supervolcanoes. It's not even the type of volcano that matters as much as how violently the volcano erupts. An eruption is classified as major or VEI 6 or greater when it ejects more than 10 billion cubic feet or 300 million cubic meters of volcanic material or tephra. For context, that's roughly the size of Mount St. Helens in Washington state. Major eruptions are rare, occurring only about once every few hundred years, but the really big explosions are considered super eruptions. That's when a volcano ejects more than 300 billion cubic feet or 10 billion cubic meters of material, and happens maybe once every 10,000 years. The largest super eruption ever recorded was the 1883 eruption of Krakatoa in Indonesia, which ejected 3,000 cubic miles or 12,000 cubic kilometers of debris and was heard nearly 2,000 miles away in Australia. The sound waves generated by the explosion killed more than 36,000 people, and while that's a horrific loss of life, it's not quite on the scale of a truly apocalyptic scenario, which is why we have a level above super eruptions called the ultra eruptions. Ultra eruptions are so massive that they eject more than 10,000 cubic miles or 40,000 cubic kilometers of material. Only 3 ultra eruptions have occurred in the past 26 million years, all in the same place. The most recent was the Huckleberry Ridge eruption in what is now Yellowstone National Park, which happened about 2.1 million years ago. Before that, there was the Mesa Falls eruption in Idaho, which blew its stack about 2.3 million years ago, and the oldest one in the series, the Lava Creek eruption, occurred 2.5 million years ago. All 3 of these ultra eruptions were caused by the same magma source, the Yellowstone hotspot, which is a plume of hot rock rising up from deep within the Earth's mantle. The thing is, it doesn't seem to want to stop anytime soon. As the North American plate continues to move over the hotspot, new volcanoes will continue to form. And while we consider ourselves pretty lucky that the hotspot chose to make its home under Yellowstone National Park instead of, say, the middle of the contiguous United States, the same can't be said of places like Indonesia, where the subduction zone where the Australian and Eurasian plates meet is home to a number of potentially supervolcanic threats. Indonesia sits on the infamous Ring of Fire, which stretches from New Zealand up through Japan and then through Russia before continuing south along the coast of North America. This horseshoe-shaped belt is responsible for 75% of the world's earthquakes and 90% of its volcanoes. It's also home to at least 130 potentially supervolcanic threats. One of the most active is Mount Ibu, which sits off the coast of the Indonesian island of Sumatra. In 2021, the Indonesian Center for Volcanology and Geological Hazard Mitigation, or PVMBG, began monitoring increased activity at the volcano after it began to show signs of unrest in August of that year. The PVMBG raised its alert status to the second highest level after recording 239 shallow earthquakes in a 2-week span. And in October, there was a noticeable uptick in the frequency of steam-driven explosions. Local authorities urged residents living near the volcano to stay vigilant and keep their emergency preparedness kits up to date. And just this past June, Ibu put on another impressive display when it emitted a thick column of ash, nearly 10 kilometers into the air. No word yet on whether the local residents were able to spot the colorful plume against the backdrop of last month's annular solar eclipse. While Ibu may be the most active volcano in the region, it's far from the biggest. That title belongs to its neighbor, Mount Sinabung, which sits on the northern tip of Sumatra. Since 2010, Sinabung has been in a constant state of eruption, spewing ash and gas clouds hundreds of meters into the air. In September of 2016, it produced the largest eruption of the decade, reaching a height of 25 kilometers. Just to give you an idea of how tall that is, it was about the same height as the 1980 eruption of Mount St. Helens in Washington state, which is the second tallest in U.S. history. Luckily, Sinabung gave the more than 30,000 people who live within 5 kilometers of the volcano plenty of warning. Unlike the 1815 eruption of Mount Tambora, which remains the tallest in recorded human history, Tambora, also located in Indonesia, gave little to no warning before it blew, so when it erupted, killing an estimated 92,000 people, no one was prepared. While it's always difficult to predict exactly how a volcanic eruption will play out, scientists have gotten much better at giving people advance notice that an eruption is imminent. Like many volcanoes, Sinabung gives off visible signs of unrest before it erupts, including steaming, gas emissions, and ground deformation. Scientists can use data collected by instruments placed on the volcano to build models that help predict future behavior. But despite our best efforts, we still don't have very much time to prepare for a supervolcanic eruption. A 2017 study found that even with the best warning system in place, evacuating the surrounding area would take at least 2 days, and probably more, like 7 to 10 days. And let's face it, 2 days is probably all you'll get before a super eruption turns to dust. In 2019, researchers led by Jonathan Castro-Murgas of the University of Bristol used climate models to simulate the effects of a large volcanic eruption. They projected that depending on the altitude of the eruption plume, it could inject between 5 and 100 trillion particles of sulfate aerosols into the stratosphere. These aerosols reflect sunlight back into space, leading to global cooling. In the worst-case scenario, temperatures would drop by 6 degrees Celsius, which would trigger a volcanic winter. At that point, the risk of famine and societal collapse would be uncomfortably high. So yeah, while a super or ultra eruption won't likely be the end of the world as we know it certainly would change. As technology improves, we will become even better at detecting signs of unrest at volcanoes and issuing timely warnings. But in the event of a super eruption, there simply isn't much we can do to prevent the devastation that follows. Our best bet is to improve early warning systems and make sure we have plans in place to minimize damage. Thanks for watching this episode. If you want to help us explain even more mind-blowing space stuff to the whole internet, we have a Patreon where the people who want to support the work that we do that so that we can keep doing it. You can find it at our support page.